This paper is developing a cognitive assistant for the audit plan in the brainstorming. And this is an interesting paper and in the beginning stages introduced by Professor Miklos and Professor Lee. Um, I think I can just jump into the design for this paper.
Okay.
Okay, so this is the cognitive assistant to improve the audit plan. The figure one shows the main features of the typical cognitive assistant and how these features can benefit audit brainstorming session. So the first one is information retrieval. Just like using Apple Siri in a brainstorming session, auditors can ask for information such as financial statements, regulation, or analytical procedures guideline that related to the risk assessment. And the second one is recommendation support. So just like Spotify, the system will recommend us some music that we might also interested based on what we have listened. So when auditors interact with the tool during the brainstorming session, it will generate recommendations to auditors for discussion on potential risk areas. And the third one is adaptive learning. So when cognitive assistant system is interacting with auditors, the system will learn from the user's preferences over a wide range of functions. When more auditors use the tool in brainstorming discussions, the tool will increase its knowledge base and adapt itself with auditors' thinking and become smarter. The fourth is service delegation system, which can evoke other apps to complete tasks such as setting a timer, sending messages, creating reminders, or responding to questions. Allow the engagement team members focus more on important tasks in the risk assessment conversation. And Figure 2 shows the proposed architecture of the audit domain cognitive assistant. The first one is the interface. It's a proposed tool named Lookup. So users should be able to browse the tool when calling Lookup. And when auditors start a brainstorming meeting, he needs to select the industry, client, and companies, and the position of his positions in the engagement team from the homepage. The selection of industry and client name is the control for the information access. And the select of the position of the user is because the cognitive system assistant will be able to learn and memorize the questions and actions performed by different users. Then the system can provide relevant recommendations to the following users. And we can see that this picture shows you may also interested in is the recommender system. As more auditors interact with the tool, it will react better by providing more targeted recommendations. The second part is the architecture. So the auditors can interact with the proposed tool by talking to it or typing the question they want to ask. So the query classifier will decide if the comment is an action or a question. If it is an action, the comment is sent back to the system to execute the required application. And if this is a question, the comment goes to a QA, the question and answering system. That will extract information from the question such as the database from the previous users. The third part is the background supporter. So introducing applications from the third-party apps that are linked to the proposed audit cognitive assistant system. For example, if auditors may be interested in knowing new information such as the economic factors or latest events about the client during the risk assessment, then an app of web search, web search, will allows information to be used through online search engine. And for the knowledge database, the system also support for the domain knowledge. unstructured data and knowledge about the users. So this is also from the collect from the previous auditors when they are using this system. And the most important components for the cognitive assistant include speech recognition, spoken language understanding, and language generation, QA system, dialogue manager, and text to the speech. It is a little bit like the machine learning and the AI system. So the figure 3 shows an example of how a current cognitive assistant is structured. So the first one is speech recognizer. This is an intelligent personal assistant such as Apple Siri and Amazon Echo machine learning techniques to build smart voice recognition system. And the second is spoken language understanding. So it's a natural language processing uses computational technique to learn and understand how human language content. The third one is dialogue manager. This is also the QA system that provide answers to questions that rely on complex like natural language processing techniques. Um, the QA system developed has a long history with three main QA systems, such as the IR-based question answering and knowledge-based question answering and hybrid approach. So, one crucial feature of the Watson's Deep QA is its cognitive computing technology, which means it can learn and improve machine knowledge from their interactions with humans. So the last figure, this figure 4 shows the proposed QA system architecture based on the existing QA models. So first one, users can ask questions that are normalized to be accessible for the query generation. And if the QA system can find answer in the relational database, such as the traditional domain QA system, then the NL answer generating module will generate an answer to the user. However, if the system cannot find the answer in their database, so they will search online or search the outside information and generate the answer candidates and provide you the best answer for your question. So the computer assistant audit techniques has been used by auditors to improve the audit efficiency. Different from existing the CATS model, this paper proposed audit plan cognitive assistant provides a new method to manage audit knowledge. One limitation for this paper is that the proposed framework needs to be tested through experimental brainstorming meeting. And for the future research, we can focus on two topics. The first one is how the proposed framework and the QA system should be improved. And the second one is develop a demo for the proposed cognitive assistant and test it using the experimental brainstorming meetings in the audit plan. That's it. Thank you.
Thank you. I have a question to everyone. Have you noticed how different is the nature of the research on papers 1, 2, 3, 1, 2 together, 3, and 4? The first ones, 2 were basically empirical research, reasonably old, but kind of dealing with this topic very, very tightly in the standards of the time. Paper number 3 was kind of very nice, very, very elucidative review of the literature and of the issues. Very well done, although it doesn't deal with a couple of issues I raised. And Chao Li's dissertation basically was speculative on developing a tool and very different in nature. And interesting question, or what you think is going to happen in the future, or what I think is going to happen in the future, is I think we are going to kind of move more into this direction of speculative research or forward-looking research, because technology, particularly intelligent system predictive systems, allows you to do it with more confidence. I don't know, but it's very different research types. Charles' dissertation, the baseline of it was of kind of think aloud methodology, which is a accepted methodology we already covered, mock paper, and that basically we did the think aloud with engagements of KPMG, and gave us a lot of insight in the brainstorm thing. But then the other part of it was Chow investigating what existing systems do and what this particular system could do. And I go on talking to the firms, and I keep telling them they really shouldn't be doing this mammoth expert system, this mammoth AI systems, Watson system. They should focus on a cognitive aid on the narrow domain of the audit, which could accumulate thousands of audits experiences and help them.